Section 6.3 Solutions about singular points. A definition. A homogeneous linear second-order differential equation of the form a2 y double prime plus a1 y prime plus a0 times y equals 0 can be rewritten in the standard form as y double prime plus p times y prime plus q times y equals 0. Definition. The regular and irregular singular points. A singular point x equals x0 is said to be a regular singular point of the differential equation of the form a2 y double prime plus a1 y prime plus a0 y equals 0 if the functions the lowercase px is the product of the x minus x0 and the capital Px and the lowercase qx is the product of the x minus x0 to the power seconds times the uppercase function qx are both analytic at x subscript 0. A singular point that is not regular is said to be irregular singular point of the differential equation. For example, if x equals x0 is a regular singular point, the differential equation will be of the form x minus x0 to the second y double prime plus x minus x0 times lowercase px y prime plus lowercase qx y equals 0, where lowercase p and q functions are analytic at x equals x0. Any second-order Cauchy-Euler equation of the form ax squared y double prime plus bxy prime plus cy equals 0 has a regular singular point at x equals 0. Examples. Determine the singular points of the given differential equation. Classify each singular point as regular or irregular. Identify the lowercase px and lowercase qx function for each regular singular point. Part 1. We have the differential equation as x squared minus 4 raised to the power second y double prime plus 3 times x minus 2 times y prime plus 5 times y equals 0, and we write this in the standard form to get y double prime plus 3 times x minus 2 over x squared minus 4 to the second times y prime plus 5 divided by x squared minus 4 to the power second times y equals 0. And we get the uppercase px from the standard form as 3 divided by x minus 2 times x plus 2 to the second power, and the capital Qx or uppercase Qx function as 5 divided by x squared minus 4 to the power second, or we can factor this as x minus 2 squared multiplied by x plus 2 squared. From the capital P and Qx, we can see this as the Px and Qx are not analytic at x equals 2 and x equals negative 2. Therefore, x equals plus and minus 2 are singular points. And then we are going to identify or classify each singular point as regular or irregular. Starting with the point x equals 2. For x equals 2, we're gonna form the lowercase px function from x minus 2 times the capital Px, which gives us the function 3 divided by the quantity x plus 2 squared, and the lowercase qx as x minus 2 squared times the uppercase function q x to get the equation 5 over x plus 2 to the power second. So both lowercase p and lowercase qx functions are analytic at x equals 2. So we can say x equals 2 is a regular singular point. Next, we check the x equals negative 2. The function px is formed by x plus 2 multiplied by the uppercase px. And then we get the function as 3 divided by x minus 2 times x plus 2. And the lowercase qx is from x plus 2 to the power second multiplied by the uppercase qx to get the function 5 divided by x minus 2 to the power second. So at x equals negative 2, the function lowercase px not analytic because we have the factor x plus 2 there, but it is analytic at qx since at least one of them is not analytic. So we can say that x equals negative 2 is an irregular singular point. So we make a note here that the px is not analytic at x equals negative 2, where the qx is. But at least one of them not analytic. So we say x equals negative 2 is an irregular singular point.